In our introductory video, we covered the basic data types in Python such as string, integer, float, and boolean. And these data types allows you to store a single value. However, what if you need to store a list of 10 names? Would you do it like this? While this is possible, imagine being asked to store an additional 10 names. With this approach, you have to create another 10 variables and assign each name manually. The good news is that Python offers a data type that is very helpful in this kind of scenario. And in this video, I will introduce you to the first two complex data types that Python supports, list and tuples. And these data types allows you to store multiple values or a collections of values in a single variable. I will guide you on how to initialize lists and tuples, demonstrate the process of inserting new values, explain the concepts of indexing and slicing, and introduce you to the built-in functions and operations available for both lists and tuples. Just as string values are typed with quote characters to mark where the string begins and ends, a list begins with an opening square brackets and ends with a closing square brackets, like in this example list which I assigned to the variable mylist. And these values within the list are called items or elements of a list. And these elements are separated by commas or comma delimited. With list, you can store integers, floats, strings, and Boolean elements. And in this example, our list contains elements with mixed data types. We have a string hello, a floating point value 3.14, a Boolean value true, a non-type value, and an integer value 21. And to initialize an empty list, you just need to use an open and close square brackets and assign it to your list variable. Like in this example, I initialize a books variable, which is a list variable. And when creating a variable list, it is recommended to make it plural, or you can simply add the word list so that other people reading your code can easily identify that the variable is a list data type. In this example, I initialize a list variable named names with a list of names. Now, if we use the built-in function type to determine the data type of the names variable, it will return list. And when you print a list variables, it will output its value in a list format. In this example, we can see that the output is enclosed with an opening and a closing square brackets. And the order in which elements are inserted into the list is the same order to access them. Going back to this names list, if we want to access Sophia, first we need to use the names list, which is names, and then use an open and close square brackets, and inside those brackets we need to specify Sophia's index position. But how do we know Sophia's index position? Well, the first element in the list always starts at index 0, and the second element is index 1. Sophia is the third element, so her index position is 2. And now that we know her index position, we can use that inside our square brackets. Now, if we execute this code, it will print Sophia. And now, if we want to access Ava, we just need to specify index position 4, and this will return Ava. Now, the last element of the list is 1 less than the size of the list. To know the size of the list, you just need to count the number of elements. In our name list, we have a 1, 2, 3, 4, 5, 6 names. So the size of that list is 6. And the last element index position is 1 less than the size. So if the size is 6, then we can access the last element using the index 5, and this will return Logan, which is the last element in our names list. But what if you have hundreds or thousands of elements in the list? How will you know its size? Who wants to count that, right? Well, in that case, you can use the len function. Then this function will return the number of elements in the list or its size. So if we check the len of names, then it will return 6. Another way to access the last item or element in the list is by using negative index 1. So if we try negative 1, this will return the last element in our names list. Similarly, if you want to access the second to the last element, you just need to use negative index 2. And this will return Aba, which is the second to the last element. So remember, to access the first element on the list, you need to start with 0. And if you want to access it backward or from the last element, you need to start with -1. One important thing you need to know about lists is that they allow you to have duplicate element on the list. In this updated names list, notice that we have two names Olivia. If we execute that line, we'll not get any error. And if we print the names variables, you can see that we have two names Olivia in the list. To update the element of a list, similar to how we access an element, we need to indicate the element index position within the square bracket and then assign a new value using the assignment operator. So in this example, if we want to change the value of the first element, which is at index 0, we can just use that index and then assign a new value. For example, let's set its value equals to George. And now if we access again the first element using this indexing, and if we execute this code, now we can see that our first element value is now George. And if we print all the names again, we can see that Carter no longer exists because I replace it with the new name, which is George. Going back to our names list example, if we want to access an element, we just need to specify its index position. For example, Emma is at index position 2. So we use the names list and indicate 2 within the square bracket, and this will print Emma. And if we want to update the element, similarly, we need to specify its index position and then assign a new value. For example, let's use Mary using the assignment operator. And now if we execute that code and if we check the value of the index 2 element, it now shows Mary. And in the case that you specify an index that exceeds the number of your elements, Python will give you an index error, meaning that your index is out of range. And now let's talk about the simple common list operation. And let's start by adding a new element to the list. But first, let's print our names list again. To insert an element at the end of the list, we can use the append operation and then indicate the element value within the open and close parentheses. And this dot notation here indicates that we are invoking the method append on the names list. Now, if we execute this code and print our names list variables, we can see that we have a new element Emily at the end of the list. Let's append another one. This time it's Lucas. So if we execute this code and again print our names list variable, we can see Lucas at the end of the list. If we use the len function, now the size of our names list is 8, meaning that we now have 8 elements within the names list. And take note that the append method can only add one element at a time, and the element is always added at the end of the list. And in the case that you want to add a name but you don't want it to be appended at the end of the list, then another method you can use is the insert method. This method requires two parameters. First is the index where you want the element to be inserted, and second is the element to be inserted. In this example, we want to insert the name Grace at index 3 of the names list. So if we execute this code and again print our names list variable, we can see that Grace is now at index position 3 and all the other elements after that index shift to the right of the list. And in the case that you have multiple names that you want to add to your list and their index position doesn't matter, then you can use the extend method. This method allows you to specify a list of elements, and when executed, it will append those elements at the end of the list. And notice here that the value we are passing to this method is a list. So if I execute this line and again print our names list variable, we have now Aiden and Liam at the end of our names list. And with lists, we can also perform some arithmetic operations. In this example, I initialize two names lists, names 1 and names 2, and both these lists contain three name elements. And what do you think will happen if we add these two lists and assign the result to a new variable all names? So let's execute this code. And let's try to print our all names variable. Now we can see that using the addition operation on two lists, combine the elements into one list. In this example, the all names variable is a brand new list that holds the combined names from names 1 and names 2. And if we check the names 1 variable, we can see that it still has its original list of names. And we can also use the multiplication operation to a list. For example, if we multiply names 1 by 2, then Python will create a new list and repeat each element from the original list twice. If you know the element value and you want to know its index position in the list, you can use the index method and specify the element within a parenthesis. So for example, if you want to know the index position of the name Ethan, it will return 1 because Ethan is the second element which is at index position 1. But be careful when using the index method as it is case sensitive. If you specify a lowercase e in the name Ethan and execute this code, then you will get a value error because the element should be an exact match. And it's the same error if you access an element that does not exist on the list. Let's print our names one again to see its names. And if you want to remove an element from a list, you can use the remove method and specify the element value. So let's try to remove Ethan. And now, if we print names 1, we can no longer see Ethan on the list of our names. So here I initialize names 1 again, and you can notice that we have two names, Ethan. And in the case that you remove the element Ethan from the list will only remove the first instance of that element. So if we remove Ethan and print the names1 variable, we can see that only the first instance of Ethan was deleted and the second instance still exists. And now I want to quickly introduce you to the membership test operator in. So this operator checks whether a specific value is present in a sequence like a list, tuple, or string or set. And in this example, checking Ethan in names 1 will return true because Ethan is one of the list element. And this is helpful in future code before you delete an element where where you can check if it exists first so you will avoid getting an error instead. And if the element is not present within the list, it will return false. Python also offers a method to organize our list. So if you want to sort your list alphabetically, then you can use the sort method. And using this method, it will change the order of element in the list. So if we sort our names and print the names list, now we can see that the second element is now Lily, which has now the index position 1. And if there is a sort method, there is also a reverse method. If we use the reverse on our names list and print the names, now the elements are printed in reverse order. It again changes the order of elements. So now Olivia is the first element and Carter is the last. Let's sort again the names to organize it alphabetically. And let's check if it works. And yes. Another useful operation in the list is the pop operation, which removes the last element from the list. So if we use the pop operation within the names list, then it will return the element that was removed from the list, which is Olivia, because that's the last element in our names list. And now if we print our names list variable again, we can see that we now have only one name, Olivia. So we saw earlier that the pop operation returns the element that was removed from the list. And it is helpful if there's an additional step that you want to do on that pop element. So for example, we can assign the result of the pop operation to a variable so that we can access that element again if there is an additional step needed. Now, if I execute this code and if we check the value of the pop name variable, then it will show the element that was removed from the list. If we print our names list variable again, we can see that the remaining name Olivia is also deleted. So let me initialize again the names list with its original values. Another useful operation in the list is the count operation, which returns the number of times an element appear in the list. For example, if we count Mary, it will return 1. But if we count Olivia, it returns 2 because we have two elements named Olivia. In the case that you want to remove the duplicate element from the list, one quick technique that you can use is by converting the list to a set. You just need to use the set function and then pass the list variable. If we execute this code, it will output the converted list to a set. The main difference of a set to a list is that it is surrounded by a curly braces while the list uses square brackets. And also a set does not allow duplicate values, and that is why that we can now see that we only have one name Olivia in this converted list. And let me initialize a new names list again. And here is another useful operation in the list, which is the clear operation, which removes all the elements from the list. So now if we clear names 1 and try to print it, now it shows that names 1 is an empty list. And now let's talk about the different ways to copy a list. So first I want to show you how to make a deep copy of a list in Python. And to do that, we need to import the copy library. And remember our names list, it contains 6 name elements. And to create a deep copy, we need to use the copy we imported and invoke the method deep copy and then specify the data that we want to copy, which in this case is the names list. And then copy will be assigned to the copy names variable. Now let's execute this code. And now if we print both of these names lists, we can see that they have the same elements. So what is a deep copy? Okay, let's try to remove the name Olivia from the names list and execute this code. And now if we print both names again, we can see that the changes we made on the names list did not affect the element from the copy names. And that is what a deep copy is. When we create a deep copy of the names list, Python creates the copy names in a separate memory location. So any changes we do in one of these names will not affect the other. Now the opposite of deep copy is the shallow copy, wherein the changes we made on one of the objects are also applied to the other object. And let's use the names list again to demonstrate this concept. To make a shallow copy of our names list, we simply use the assignment operator. And now if we print both these names, we can see that they have the same elements. So let's try to update the element at index position 2 to a new name Bill. So now if we print both these names again, we can see that the changes we made on the names list are also applied to the shallow names list. It is because both the shallow names and the names list variables refer to the same memory location when we use the assignment operator. And so far, most of our example uses or use string values. Now let's try some numeric values and explore the built-in function we can use on them. Here we initialize a list variable nums with a list of numeric values. So let's execute this code. And to check the maximum or the largest value within the list, we can use the max function. So if we execute this, this will return 32, which is the largest value or number in our nums list. And to check the minimum value, we can use the min function. And with any list values, we can always use the len function to determine the size of the list or the number of elements within the list. And similar to string values, we can also use the sort function with numeric values. And this will sort the values from the lowest to the highest number. Let's execute this code and let's print our nums list. And here we can see that the value of our nums list are sorted from lowest to the highest number. And if you want to print it in reverse order, then you can also use the reverse function. So now if we print the nums variable again, we can see that the order of our numeric values are now uh, in a reverse order. Another special method or operation you can use with numeric list values is the sum function, which adds all the list element. So executing this code will return 127, which is the sum of all the numbers in our list. And we can also use an augmented operation like in this example. We multiply our nums list by 2 and assign the result back to the nums variable. So what do you think will be the result of this operation? Well, let's execute this and let's print the nums variable to find out. Well, you might think that the operation will multiply each number within the list by 2, which is not what happened. Instead, the operation duplicates all the elements from the list, and this is the same result if we use this operation with string values. But take note that this operation only works with integer values. If you try to multiply nums with a floating point value like 1.2, then you will get a type error. Also in Python, the value 0 is considered false and any other value except 0 is considered true. And the all function checks if all the elements within a list are true. If not, it returns false. So this will return false because our element or the element in our list is 0. And if we specify a value 1 to this function, and since it's the only element and it's true, then it will return true. And this is a bit tricky, but an empty list also returns true. Now, if we try to specify two values, 0 and 1, the result will be true because we have a 0 value. So now, if we use this function on our nums list variable, it will return true because we don't have a 0 value in our nums list. Now let's talk about the slicing operations in lists. So let's go back to the name list example. And previously, we used to access individual elements from a list using their index position. But with slicing operations, it allows us to access a range of elements from a list. Here is an example of slicing. First, we use the list name, then use a square brackets, and inside those brackets, we specify two values separated by colon. And this format tells Python that we want to access a range of elements from the names list. The first value on the left side of the colon indicates the start of the range or the index of the first element that we want to access. The second value on the right side of the colon indicates that we want to access the element up to index 4 but not including the element at index 4. So if we execute this code, it will print Carter, Olivia, Mary, and Mason. And if you want to access only the first two elements, then we use 2 for the second value because the second element is at index position 1 and this only print Carter and Olivia. Again, using the len function, we will know the size of our list. So in this example, the size of our names list is 6 because we have 6 elements on that list. And if you want to print all the elements from the list using slicing, then we can use the length of the list as the second value. So in this example, we use 6 and this print all the element in our list. Another way to access all the elements from a list without knowing the list size is by omitting the second value. So here I only indicate the start of the range, which is at index 0, and it will automatically be considered that we want to access up to the last element. So now if we execute this, it also print all the element in our list. And similarly, if we omit the first value, Python will set it to the default value, which is the first index 0. So executing this command will also print all the element of the list from the first index. And we can also use a negative value in a slicing operation. In this example, we tell Python that we want to access a range of elements from our names list from the first index up to the element at a negative index 4, but not including that element. In our names list, Mary is at index -4 because Lily is -1, -2, -3, and -4. So if we execute our code below, it will only print Carter and Olivia because Mary is the last index element and we should not be including that in the slicing operation. And another example which I want you to guess. So pause the video and take some time to think what will be the output of this code. So what's your guess? Okay, let's analyze first. So this range starts at index -4 and the element on that position is Mary. So Mary is the first element and the element at -1 index position is Lily. So that element will not be included. So if we execute this command, it should print Mary, Mason, and Olivia. Take note that if you specify a range that makes no sense, then Python will return an empty list. And now in slicing operation, there is an optional parameter called step. And this parameter determines the interval between elements in the slice sequence, and it specifies how many elements to skip between each selected element. Let's print our names list again. And, and in this example, we now introduce the two columns which serve as a divider for the three parameters. The first parameter is the start of the range. The second or the middle parameter is the end of the range. And the third parameter is for the step interval. If we omit everything, then Python will use the default value. So for the first parameter, it will be set to 0. The second parameter will be set to the size of the list, and the third parameter will be set to 1 as default. So if we execute this command, it will print all the elements from the list. And now if we try to change the step value, for example, it is 2, then the slice operation will only take every second element from the start index of the list. So once we execute this code, it now only prints three names in index position 0, 2, and 4. And if we try step 3, then it will only print Carter and Mason from index 0 and index 3. And you can influence the result of the step operation by changing the start parameter. If I indicate 1 instead of 0, and now if we execute this code, the output is different. Slicing starts at index position 1, which is Olivia, skip Mary and Mason, and then take the element at index position 4, which is Olivia. And if you want to access the names list in reverse order, you can achieve it by using step -1. So if we execute this code, now our names are printed from the last element, which is Lily, up to the first element, which is Carter. And we can also try to use negative step 2. So Python will start with the second element from the end and take every second element going to start or to the start of the list. So Olivia is the element or the first element, so it's included. Skip Mary, take Mason, skip Olivia, and then take Lily. And if you assign the result of a slicing operation to a variable, then you will be creating a deep copy of the element within those results. So here we try to slice all elements from the list and assign the result to copy names. So now if we execute this code, we have a deep copy of all elements from the names list. And if we print the value or the element of the names and copy names, we can see that they both contains the same elements. Now let's change the value of the first element in the name list to George. And if we execute this, and if we print again both names, we can see that the changes I made only affect the names list and not the copy names list. And it is because copy names is a deep copy of the names list and this variable have a separate location in the computer's memory. This time, let's consider this variable x, which is a string data type, as a list of characters. And let's treat each of those characters as element of a list. So if we want to access individual characters or element from this list, we can use indexing and specify the index position. So in this example, index position 0, 1, and 2 will return the first three characters, which are L, I, M, N. One difference of a list and string is that a string is immutable, meaning that we can treat the string variable like a list, but we cannot change its individual element using indexing. So if we try to access the first element and assign a new value to it, for example D, and if we execute this, it will or we will get a type error. And if you want to assign the individual characters of variable x to individual variables, then you can do it this way. So now if we execute this, and if we print the value of the variable a, b, c, d, and e, it shows the corresponding letters from the x variables. Take note that the number of characters within your string should match the number of variables. Now, in the case that you are only interested in the first five characters, then instead of creating variables for the other characters, you can simply use an underscore, which tells Python that you are not interested in the other characters. So now if we execute that code, that is a completely valid syntax. And again, if we print the value of the variable a, b, c, d, and e, we can also see the same result. Now I want to introduce the input function, which allows us to get a value from a user and store that value to a variable. In this example, we ask for the user's favorite book. So for example, if I execute this and enter a book, for example, magic of, the magic of thinking, I don't spell that correct, big, which I highly recommend to you this book. And if I hit enter, then if I check or print the value of the variable fab book, we can see that it contains the value we provided. And we can treat the value of that variable as a list of characters. So let's perform a slicing operation using the start 0 and then omit the last element, and this will return all the characters from the fabbook variable. Now if we use 3 as the range and index, it will return the characters from index position 0 to the index position 2, which will return the. And similar with list, we can also use a negative index position. So in this example, using the start 4 and last element, but not including element 4, it will return magic of thinking. And of course, we can also try adding some step, for example, 2. So here, if we execute this, it will print every second element from the string, starting from index 0. Another useful function that you can use with a string is the starts with, which returns a Boolean result. Take note that it is case sensitive, so checking if a book starts with an uppercase T, it will return true. And another function is the ends with function, which also returns a Boolean result. So if we check if a book ends with a W, it will return false. And you can also count the occurrence of character in a string using the count function. So if we check the occurrence of the character A in our fabbook variable, it returns 1. And to convert a string to a lower and uppercase, you can use the lower function and the upper function. And if you want to check if a letter or a word exists within a string, then you can use the find function. And this will return the starting index position of the value you specify. So in this example, it will return 4 because the M in magic is located at index number 4. And in case that you specify a value that does not exist in the string, then it will return negative 1. Another similar command is the index function, which also returns the index position of the first element from the specified value. So if we check magic again, it also returns 4. However, for index, if we specify a value that does not exist within the string, then it will throw a value error. which is the difference compared to find, which returns -1. And another common function used in a string is the split function, which extract words from the string depending on the delimiter specified. And the result of this operation is a list. So for example, if we use this function in our fab book and then store the result to the split text, if we execute this code and check the value of the split text variable, now we can see that it is a list result which contains every word from our fabbook variable. And the opposite of split is the join command, which combined a list element using a join character. In this example, we use a hyphen or a dash. So if we execute this code, then we can see all the words from our fabbook variable are now concatenated by a hyphen or a dash character. And you can also directly do this by indicating a join character, like in this example where we join each word with a pipe character. And if we execute this code, now instead of a hyphen, we can see a pipe character between each of our words in the pubbook variable. And here is another string example where I assigned our channel name coding module to the variable name. If we check the size of this string, using the length function, it returns 13. And knowing that size, we can access all the character from that string using a slicing operation. The starting index is 0 and the last index is the list size, but not including the element on that position because technically there is no element on that position. And it will return all the characters in that string. And similar to a list, we can use the step parameter to skip some characters. So if we execute the syntax, then it will only capture every second character from the first element at index 0. And if we want to reverse the characters and step backward, we can use the negative index. So for example, -2, which again skips every second characters from the indicated first index position. And this will return these characters from our coding module name value. Okay, so one exercise for you. How can I get the word coding from this string using slicing? And you can pause the video and think about it. So I guess you have the answer now. Well, there are different ways to do this. Let's see all those possible syntax. So the most common is to start with index 0 and then use 6 as the last index, and this will output coding. And you can also omit the first character or the first index and it will be set to the default, which is 0. And again, this will output coding. And you may also use a negative last element index. For example, is 7 and it will also result to coding. Also, you can use both negative parameters, for example, -13 and -7, and it will also result in coding. And step is not necessary here because we don't want to skip any letters to print the word coding. Now let's create two variables, str1 and str2. Then let's split the name variable using the space delimiter or space as a delimiter. Now if we print this variable, str1 is coding and str2 is module. Remember that if we want to convert this string to uppercase, we can use the upper function and this will return the word coding in uppercase format. But if we check the str1 variable, we can see that it's still in the original format. It's because invoking the upper function from the str1 variable did not actually change the value of that variable. It only shows what will be the result if we invoke the upper function. So if you want to permanently store the uppercase format of the variable, you have to assign the result of this operation to another variable. In this example, we assign the result back to the str1 variable. So now if we execute this code and again print the value of str1, now we can see that coding is in the uppercase format. In Python, there is also a function that you can use to check if all the characters in the string are in uppercase. That is the isUpper function. So now if we check str1, then it will return true. And on the other side, if we want to check if all characters in the string are lowercase, we can use the isLower function, which will return true if there are no uppercase letters. So if we check str1 using this function, then it will return false because all the letters in this string are in uppercase format. And now let's convert str1 to lowercase using the lower function. Then let's check again if all the characters are now in lowercase format, and this time it will return true. And now the other complex data type in Python is tuples. A tuple looks just like a list except that you use a parenthesis instead of a square bracket. And similar to list, you can also store a mix of data type like in this example. And the value that a tuple holds are called fields. Similar again to list, each value in a tuple is separated by comma. And once you define a tuple, you can access individual fields by using its index position just as you would for a list. In this example, if we print my tuple 0 and my tuple 1, it will return the values at those index position which are hello and 3.14. And if you want to determine the data type of a tuple, you can always use the type function and it will return tuple. And to initialize an empty tuple, you just need to use open and close parentheses. And if we check again the data type of this variable empty tuple, it will return tuple. And almost all operations that we can do to a list, we can also do in a tuple. For example, the addition operation in this example, we have a string tuple that contains string values and an integer tuple that contains integer values. If we add these two values using the addition operator and assign it to the mixed tuple variable, that is a valid operations. So now if we execute this, and if we print the value of the mixed tuple, it will return the combined fields of the string tuple and in the integer tuple. And we can also use the multiplication operation on a tuple. In this example, if we multiply str tuple by 3, then Python will output a new tuple that contains the str tuple fields repeated 3 times. In Python, every time you assign a value to a variable that is separated by a comma, it will be interpreted as a tuple. So here, if we assign the value 1, John 2.6 to variable myBar and execute this code, now if we check the value of the myBar variable, we can see that it outputs a tuple value containing 3 values we assign. And we can also do multiple variable assignment using a tuple. In this example, we will assign the fields in our myBar tuple to variables A, B, and C. So now if we execute this command and print the value of variable A, B, and C, we can see the original values 1, John, and 2.6. But take note here that in doing variable assignment that way, make sure that the number of fields in your tuple matches the number of your variables, because if not, then you will get a value error. And similar to what we did in string previously, if you are only interested in the first two values, for example, then you can use the underscore in your assignment operation. So like in this example, if we don't want to store the third field or value, we simply use the underscore instead of creating a variable for that field. Now, this example here is called a nested tuple because we have another tuple value within a tuple value. And again, this example here is a mix of data types with a nested tuple and a list. This tuple contains four fields. The first two are string values, the third is a list value, and the fourth field is a tuple value. And accessing individual fields in a tuple is similar to a list using an indexing operation. So we specify the tuple name, use the square brackets, and within those brackets indicate the index position of the field. So in this example, John is the field value at index position 0. So if we execute this code, then it will return John. If we want to access the list value from the tuple through manual counting, we know that's index position 2. So if we index mixed tuple with 2, then it will return that list. And in the case that you want to access the individual value within the list, then you need to use a double square brackets for indexing. So for example, if we want to output the value 3 from the list, the first square bracket index is the list index from the tuple. And then on the second square bracket, the index we'll use is the index position of 3 in the list. So again, index always start at 0. So if we check this, the value or the value 3 is at index position 2 of the list. So to output that value, the index is mixed tuple 2 and 2, and that will return the value 3 from the list value or list field. Now let's initialize a simple tuple that contains a list of numeric values. And let's print that variable value, which also contain the same fields or elements. And if you want to know the size of the list, you can also use the len function. And another similarity with a list, you can also perform a slicing operation on a tuple. Take note that when you slice a list, it will return the slicing result enclosed by square bracket indicating a list data type. When slicing a tuple, it will return the slicing result in parentheses, which indicates that it is a tuple data type. You can also perform other operations on a tuple like the sum function, which add all the values in the tuple. And you can also convert a tuple to a list using the list function or convert it to a set using the set function. Okay, so now we know that tuples are just like lists. So what's their difference? Well, a list is mutable, meaning that you can change a list value using the assignment operation, while a tuple is immutable, meaning once you create a field in a tuple, it cannot be changed because it does not support the assignment operation. Let's quickly print the values of our nums tuple. And now let's try to change the value of the first field to 25 by using the index 0. Now if we execute this code, we will get a type error, and here it clearly says that a tuple object does not support item assignment. In a tuple, you can access its fields using indexing, but you cannot update them. But here's a tricky part in a tuple. In this example, we have a tuple containing 4 fields. The first 3 fields are simple numeric values, and the fourth field is a list value. Now, if I execute this, and if I try to update the value of the first element in the list, which is 4, then I can index that element using num2 and then index 3 and index 0. And then I will assign a new value 7. Okay, so do you think Python will allow this? Well, if we execute it, we don't get any error. And now if we print nums2, we can see that the first element in the list is now 7. So to answer the question, Python did allow it, but why? Well, it's simple because a tuple is immutable, but again, a list is mutable. And because of that, even if the list value is within a tuple, we are still allowed to update its element. And aside from changing a tuple value, a tuple also doesn't support item deletion. If we try to delete the first field in the nums2, then we'll get a type error. However, deleting the complete tuple is allowed in Python. But if we access that variable, then we will get a name error because that's already deleted in our computer's memory when we use the del function. So here is an interesting function that you can use with a tuple. In this example, if you were given 2 sets of data, the first set is, for example, the attributes, and then the second set is the values, and you are asked to pair this data, then in that case, you can use the zip function. So we just need to use the zip function and specify the 2 datasets. In this case, they are our 2 tuples, tuple at and tuple bal. Then let's assign the result to a variable named zip. And now if I execute this and if I print the value of the shift variable, then we can see that it's a memory location where Python placed this object. If we want to see the paired result, we need to convert it to a tuple using the tuple function, then assign the result to a variable. In this example, it is result. So now if I execute this and print the value of the result variable, we can see a tuples of tuples, where each field contains a pair of data from the first and second tuple. And if you want to convert the result back to its original format, you just need to use the zip function. This time you need to include the asterisk sign within the parentheses. Don't worry about what it means yet. We'll discuss that separately. Then we assign the result to variable x and y. So now if I execute this, now if we print x and y, we can see the original tuple values. And this zip function, we can also use it in a list. In this example, we have three list variables containing different values. The first one contains numeric values, the second list contains lowercase strings, and the third list contains uppercase strings. Now, if we want to pair these values, we can use the zip function and specify this three list variable. Let's assign it to the variable list zip. So now if I execute this, to see the result, we can convert list zip to a list. Then we assign the result to the zip result variable. So now if I execute this and print the value of the zip result variable, we can see a list of tuples containing pairs of values from the three list variables. Now, knowing the difference between a list and tuple, you can now decide when to use what depending on your need. When compared to a list, tuples are simple data structure. Use them when you want to store a set of values that should not be changed throughout the life of a program. And that is all guys for this video. I hope that you have now a deep understanding of lists and tuples. I highly recommend that you practice using these data types and use all the operations available to them so you'll get familiar and you can easily remember those functions when you need them in the future. Remember that if function, that's a cool function, right? And if you enjoyed this video and you think you learned at least, please hit that like button and subscribe to get updated on our new Python uploads. In the next video, we'll cover another complex data type, dictionary and set. I'll see you there.